let's say that we will take inception v3 model, and I said that you should open documentation. So it's really easy to apply transfer learning with this. So let's import all the stuff here. Since we will work on inception v3, let's take all the first 5 lines of code, and then let's apply transfer learning in inception v3. Well, what did we say? We said that we need to import the convolutional layer network, but only the convolutional layer part of it. So we want to include the top of our convolutional layer network, which consists of fully connected or dense layers. So to do that, we will call inception v3 from the inception v3 class, and in our inception v3 model, we will say that take our weights or take our filters or take the information from the ImageNet dataset, or take the filters that is trained on ImageNet dataset, or take the information that is acknowledged from ImageNet dataset, and then for the top part, don't include top, since we will arrange our customized fully connected layers. The include top should be or must be false. And let's say that this is our base model. And then let's say that this is our base model, and we need to create a new top of our convolutional network. We will add new fully connected layers. To do that, we firstly need to take the output of base model, and also you don't need to memorize it. You can just directly take it and apply it to your projects. My responsibility is to teach you, so I'm telling these details. However, you don't need to learn that. Learn these details actually. And also we need to add global average pooling to combine the features of convolutional neural networks with uh, our top our top of convolutional neural network, or our dense layers. So after combining these, we can add a fully connected layer that has 512 nodes, and let's say that we have real activation function, and then let's say that to avoid overfitting, and sorry, I forgot to add this, and let's say that to avoid overfitting in layers, let's add dropout, and in dropout let's say that we have 0.5 rate, and then we have another dense layer that has the same parameters, and then let's say that we are going to hidden nodes, that is the number of categories we have. Well, let's say that this is our predictions, because at the last hidden nodes we have the predictions. Now let's say that we need to combine these. What did we do now? Until that time, we take all of our inception v3 model with saying include top false. We didn't include the top of it. We just include the convolutional layers, and now we have this part, but we didn't create here. So then we created a dense layer, or our top of our convolutional layer network, but these are actually distinct. These are separated, so we need to attach them. So for attaching, what we will do, we will attach this, we will attach top of it to the convolutional layers, and we will determine the input and output of our general convolutional layer. After combining two, we need to identify that our data should enter the convolutional layer from here, from the input, and then our predictions will be the output. To do that, let me add the credit for the picture to here. I will edit it. Well, now, let's say that the first thing we should do is attaching them. To attach them, now, sorry, for the last layer of convolutional layer network, you should write a softmax here. I Now, after writing softmax, we need to combine these two models. And to do that, let's say that we need to create a model that is combined, this combination of our convolutional layer network and it's actually base model's input, and also this is our input, and also for the outputs we should identify the output and it's also predictions. Well, after combining these layers, attaching these layers each other, we need to freeze some of the layers. What are these layers? You can see that there are some weights that is trainable. So we will make these layers trainable, but for the part that uh, is that starts from beginning and until some point, we will freeze these layers and they won't be affected by backpropagation. These weights won't be changed during training. Whatever the training is, we won't change all these filters. So the only thing that we will do is just uh, making these weights affected by backpropagation. Actually, these two convolutional layers, some of these convolutional layers will affected by backpropagation, and these weights will be changed according to our data set. So the fine-tuning name comes from here. So you will just fine-tune just 2 or 3 convolutional layers for AlexNet, but for our problem we will uh, fine-tune lots of layers, but the most of it will be freezed for inception v3 case. So let's see it. So let's say that we need to see the layers. So for layer in our base model and its layers, uh, let's say that firstly do not make them trainable. So every uh, layer is untrainable. It means that these layers won't be affected by backpropagation, but actually this is for all the if you just want to adjust the weights of fully connected layers, we can do it. But to uh, there are actually 2 ways. You can uh, make these weights free, and you can freeze all of the convolutional layers. And this is a solution that you can get a good accuracy from this approach. Also, you can also add convolutional layers to the full connected layers, and some of the convolutional layers will be affected by these backpropagation with fully connected layers, and this is another solution. So there are 2 solutions that you should try, and for this I will freeze some of the layers, some of the convolutional layers, but I won't be freezing some of the convolutional layers. So to see the layers of our inception v3 model, for E comma layer in our base model layers, let's enumerate it. And let's print E and uh, our name of layer, our layer's name. Well, after training, you see 310 layers here. So let's say that until 249, let's say that until that point we freeze these layers. It means that these weights won't be changed by backpropagation, or in any case these weights won't be changed. But after that, all the layers, even all fully connected layers will be affected by backpropagation, and also it will work normally. It will work as a normal neural network. Well, to freeze only some of the layers, we will do something like that. Well, we will do this. For layer in our models layers, until until 249, make them uh, uh, make them untrainable or not trainable. And to do that, we should write layer.trainable false. And then for layer in our models layers, and after 249 layers, we should make them trainable. To do that, we need to write layer.trainable is equal to true. Now we have the layers, so there are two ways to apply transfer learning. One of them is freezing all the convolutional neural network layers, and one of them is uh, freezing most of the convolutional neural network layers, but not freezing some of the minority of the convolutional neural network layers. Freezing, we need to freeze them, and also, in any case, fully connected layers will be affected by backpropagation. So we now have no problem at that stage. We created our train mode, our image data generator before,